Hi guys, and welcome to our third video tutorial for business mathematics. And in this video tutorial we are going to proceed to the revision question paper that we commenced in our previous first video tutorial. And for this video tutorial we are going to go straight to question 2 of section B of the paper. And allow me to proceed straight into the question. Now question 2 goes: a school is preparing a trip for 400 students. The company providing the transportation services has small buses of 40 seats each and big buses of 50 seats, but has only 9 drivers available. The rental cost for a small bus is 6,000 Kenya shillings and 8,000 Kenya shillings for the big bus. Calculate how many buses of each type should be used for the trip for the least possible cost. So let us go straight into the solution to question 2. Now this is the solution to question 2, and the solution is as follows. It's done in subsequent steps. So we are going to begin from preliminary stage, and in the preliminary stage we are going to list all the components in the entire statement, and the components making the entire statement include: 1. The number of students given to be 400, small buses each of 40 seats, big buses each of 50 seats, rental cost of a small bus given to be 6,000 Kenya shillings, and finally rental cost for a big bus given to be 8,000 Kenya shillings. Let's proceed to the next step. Welcome to step 1. Let us assign unknown values to the two entities given in this statement. So let small buses, the number of small buses to be X and the number of big buses to be Y. And that is step 1. Step 2, write the objective function for the statement. For this case, our objective function is going to represent the total cost of the entire trip. So the objective function equation is going to be function f into xy equals to 6,000x plus 8,000y. Before proceeding to step 3, it's very important to note that the objective function for this case represents the total rental cost for all buses of the two kinds, i.e., or that is the total cost for renting all small buses and all big buses. Now going to use the constraints or elements in the entire statement to write a system of inequalities. And the first inequality we are going to write regarding the number of seats with respect to the number of students to attend the trip. Therefore, we are going to have 40x plus 50y is greater than or equal to 400. The second inequality we are going to write regarding the number of buses to attend the trip. Remember, we are told there are only 9 drivers. So the maximum number of drivers available are 9. Therefore, our inequality is going to be x plus y is less than or equal to 9. Remember, x represents the number of small buses while y represents the number of big buses. The third inequality is going to regard the number of small buses. And Here, the number of small passes with respect to the number of big passes should be at least 0, meaning it can be 0 and above. And that gives us the third inequality to be x is greater than or equal to 0. And the fourth inequality regards the number of big passes. And likewise, to the third inequality, the number of big passes with respect to the number of small passes can be at least 0, meaning the number can be 0 and above. And that gives us the fourth inequality to be y is greater than or equal to 0. Let us proceed to step 4. It's very important to note that before we proceed to step 4, there's a point to note. And the point here is the minimum number of seats to be allocated should be 400. Hence the use of greater than or equal to symbol in the equation 1. On the same note, the maximum number of buses to be allocated must be 9, and thus that's the reason behind using the less than or equal to symbol in equation or inequality 2. And now let's proceed to step 4. Now in step 4, we are going to find a set of feasible solutions that graphically represent the constraints. Now, this is the point. Express the first two inequalities in double intercept form. And the double intercept form is aimed towards achieving the points across which inequality 1 and inequality 2 cuts the x and the y axis. So that's the main objective here for using double intercept form, so that to enable us know exact points at which the two inequalities cut x and y axis. And let us proceed into writing or expressing the two inequalities into the double intercept form. Remember, the double intercept form is given as x over a plus y over b equals to 1. It's very important to note that the first inequality states 40x plus 50y greater than or equal to 400. Divide every aspect of the inequality by 400 because we want to ensure that the number after the inequality symbol is 1. So that's why we are dividing every aspect by 400. And if we do so, for the first inequality, we are going to have x all over 10 plus y all over 8 is greater than or equal to 1. And therefore, the points or the intercepts coordinates are going to be, for x it will be 10, 0, and for y it will be at point 0, 8. Let's proceed to the second inequality. The second inequality is x plus y is less than or equal to 9. We are going to divide both sides or each aspect by 9 so that the value after the inequality symbol remains 1 according to the rule of double intercept. Therefore, we are going to have x all over 9 plus y all over 9 is less than or equal to 1. Therefore, it will cut x-axis at point 9, 0 and y-axis at point 0, 9. And let's proceed to step 5. Now in step 5, we are going to plot the four inequalities on a graph. And this is how the graph looks like. As you can see, you will notice that for the first two inequalities, their line graph cuts or intersect at 0.54. So the coordinate 54 defines the point of intersection for the inequalities, and this the point of solution. This is what we call the feasible point. Now the feasible point is at coordinate 54. Let's proceed to step 6, and we see another alternative way of getting the feasible point. Now in step 6, we are going to use the non-graphical method or the non-graphical solution to the inequality. And the solution can be obtained by solving the first two inequalities non-graphically. The first two inequalities include or are as follows. First inequality, 40x plus 50y equals to 400. Second inequality, x plus y equals to 9. Therefore, the first step in solving this, make x the subjects in the first inequality, first equation for this case. So therefore, x is going to be 9 minus y. Next step, substitute x equals to 9 minus y into the first inequality. Therefore, we are going to have 40 into 9 minus y plus 50y equals to 400. Breaking with the bracket, 360, remember 40 by 90, that is 360 minus 40 times y, that is minus 40y plus 50y equals to 400. Collecting like terms, negative 40y plus 50y, that is positive 10y equals to 400 minus 360, that is 40. Therefore, 10y equals to 40. Divide both sides or divide through by 10. Therefore, we are ending up getting the value of y to be 4. Solve then for x. Remember, x is 9 minus y. Therefore, substituting through with the value of y, we are going to have x equals 9 minus 4. Therefore, x is equal to 5. Thus, the feasible point is 5, 4. The coordinate is 5, 4. And that is an ungraphical way to solve for the feasible point. Let's proceed to the last step, and that is step 7. Now use the feasible solution. Use the feasible solution coordinates 5, 4 to evaluate the objective function. That is step 7. And now remember, our objective function was f into xy equals to 6000x plus 8000y. That was our objective function. Now substitute xy by 5, 4, because 5, 4 is the feasible point of solution. Therefore, f into 5, 4 equals to 6000 into 5 plus 8000 into 4. That's 6000 times 5, 30,000 plus 32,000, that is 8,000 by 4, and that gives us 62,000. So therefore, the value of the objective function is 62,000. That is the total cost for the trip, or the minimum amount that would be spent over the trip would be 62,000 Kenya shillings. Let's proceed to the solution. Having obtained our objective function value to be 62,000 and our feasible solution coordinate to be 5, 4, therefore in conclusion, the number of small buses required for the trip would be 5, while the number of big buses required for this trip would be 4, and the least possible cost for the trip would be 62,000. That is the solution to the problem, or to this problem. Thank you very much, good people. I love all of you. Were it not for you, then this channel could not make any meaning. Therefore, you are present to my channel is highly appreciated, and I am praying for success to all of us. Thank you very much for now, and let us meet in the future video tutorials.